Okay. Now, why this is coming down and why this is anti-clockwise is because we make the assumption what? Positive what? Shear and positive bending moment. Okay. We make the assumption because it's positive shear and positive bending moment. Okay. So over here, V at point B is equal to minus 150 or minus 50 power 3 times by 0.8 plus 120 power 3 is equal to 80. Okay, so it's equal to 80 times 10 to the power 3. It's a constant, right? Because at point B, x is equal to 0.8. Then we take moment z at point B is equal to 0. So now we have the 50 times 10 to the power 3 multiplied by 0.8 multiplied by 0.4 is doing an anti-clockwise rotation, so it's positive. So 50 times by 10 to the power 3 multiplied by 0.8 multiplied by 0.4, right? And then the 20 times 10 to the power 3 has no distance from point B. Okay, so this is where we take our moment. Then we have plus by m at point B is equal to 0. Okay? So moment at point B is equal to 50 power of 3 times by 0.8 times by 0.4, and it's negative minus 16 times 10 to the power 3 Newton meter. Okay. So I won't call them an equation, it's a constant. So you go back to our table, right? We go back to our table. This is equal to what? This is equal to 80 times 10 to the power 3. And that is equal to minus 16 times 10 to the power 3. Okay. Very repetitive. Okay. This is the easy part. So from here, I'm going to copy the table again. I'm going to put it on the next page. You don't need to do this. I have to insert another page. Okay, so this table, come on, it did not copy the whole table. I think it's the user, not the computer. So this is P07, pardon me. Hey, stupid thing. Wait. See, Microsoft, you know, the third biggest company in the world, screwing things up. Okay, then I'll still need the diagram over here. The small version is good enough. Come on, Day, come on. Okay, so the next one we're going to do is we're going to find from point B to point C. Okay. Point B to point C. Now, all of them, I'm still doing left to right, left to right, left to right. Okay, wait, we will do right to left. So now 0.8 x to 3.2. So we know that we are going to form equation. Okay. So this is the diagram. Come on. So I'm going to sketch. Okay. So this is still 50 times 10 to the power 3 multiplied by x. This is where your point A is, right? And then at your point B, we have a force down here running at 120. Is it 120? Can't remember. Yeah, running at 120 times 10 to the power 3, right? And we know that we have a distance from here to here is 0.8. Okay. So we know the geometric datum is on the left-hand side. Okay. The distance from here to here is x. All right. So we know if that's the case, the distance from here to here is x minus 0.8. It's not 0.8 minus x, it's x equal to minus 0.8 because that value has to be what? Positive, yes or no? All right. So from here to here, this is v as a function of x, moment as function of x, and we know the distance from here to here is still x divided by 2, okay, from B to point C. So again, the first thing when you have a diagram like that, sort up the forces and sort up the what? The distance. Yes. So this distance is still x. Yeah, because x is a variable, but the limits is from 0.8 to 3.2. So the limits are different. So it's still x. Okay? So from here, we do static analysis still. So our analysis is still from left to right, right? So analysis direction. Is still left to right. The next one we are going to do right to left. Okay, I know we are feeling a bit bored. Okay, so we still do static analysis. Okay, so we will do positive is going up. Okay, so we have 120 times 10 to the power 3 minus 50 times 10 to the power 3x minus v as a function of x is equal to 0. So v as a function of x is equal to minus 50 times 10 to the power 3x plus by 120 times 10 to the power 3. Equation number 3. Okay. That is our equation. So our equation number 3 is still a linear equation. Yeah, straightforward. So next one, we're going to do some mention about moment in the z direction at the variable x is equal to 0. So this dot where I draw and highlight is where we are taking our moment. Okay, it's where we are taking our moment. So over here we have the 120 is going in a clockwise direction. So minus 120 times 10 to the power 3 multiplied by x minus 0.8. Okay. Plus the 50 times 10 to the power 3x multiplied by x over 2. Okay. And then plus m as a function of x, the whole thing is equal to 0. Okay. So m as a function of x now becomes positive minus 25 times 10 to the power 3 x squared, right? and then plus by 120 times 10 to the power 3 x minus 0.8. So this will be equal to minus 25 times 10 to the power 3 x squared plus by 120 times 10 to the power 3 x minus by 120 power 3 times 0.8 minus 96 times 10 to the power 3. Okay. Our equation number 4 is a second order polynomial equation. Okay. So second order. I'm just going to put over here second order. I'm just going to write poly. Okay. So next we fill up our table. So this is equal to b as a function of x is equal to minus 50 times 10 to the power 3x plus by 120 times 10 to the power 3. Moment as a function of x is equal to minus 25 times 10 to the power 3 x squared plus by 120 times 10 to the power 3 x minus by 96 times 10 to the power 3. Okay, this is getting boring. Next, we are going to do point C, and point C we are going to do from right to left. Okay, point C we're going to do right to left analysis. Okay, so next we are going to look at point C. Point C is where x is equal to 3.2. So it's going to be a constant. Okay, so we are going to do from right to left analysis. Okay, we are going to do from right to left. Why? Because there is less terms to look at. Okay, so watch this. Okay, datum still on the left hand side. Now the distance from here to here now we fix at what? 3.2. Right? That is our slider 3.2. So now we are going to draw, right? So this is our point D. This is our point C. Okay? One is our point D, one is our point C. And we know we have a force down here going upwards at what? What is that value we calculate? I can't remember now. I have to look. Direction is what? 40. 40 times 10 to the power 3. And that's it. Nothing already. Okay? And then we are going to assume positive shear now is going up. Okay? Hold on. Now it's going up. B. And then, hey, come on, Eugene, write properly. Going up. B at point C. And then moment is going in the opposite direction now. We do this direction because we are now doing the analysis. Our analysis direction is this way around. This is our analysis direction. And the distance from here to here is equal to 0.8. Okay. So now we do static analysis. I'm not going to write static. Okay. So summation of forces in the y direction is equal to 0. This is equal to 40 times 10 to the power 3 plus by V C is equal to 0. So V at point C is equal to minus 40 times 10 to the power 3. Okay. Then we are going to take summation about moment. In the z direction at point C is equal to 0. So we're going to take moment at the dot that I'm drawing now. Okay. So this is equal to, it's going anti-clockwise. So 40 times 10 to the power 3 multiplied by 0.8 minus, right? Minus by m at point C is equal to 0. So m at point C is equal to 40 power 3 times by 0.8 is equal to 32 times 10 to the power 3 Newton meter. The other one is Newton, and they are